we first discuss a rainbow as a natural phenomenon. This is the first one. It is a combined effect of dispersion, refraction, total internal reflection of light by spherical water droplets of rain. The conditions are there are two conditions are the first one, the sun should be shining in one part of the sky, and second one, it is raining in the opposite part of the sky. Okay, and the observer he should stand as his back towards the sun. Okay, that's a condition. When we consider this phenomena, you know phenomenon, you know that when sunlight first refracted as it enters the raindrop, which causes a dispersion inside the raindrop. As you know, violet light bend more and red light bend least, and after this bending and refraction, it touches the opposite side of the raindrop. Here we have to face, the light has to face according to total internal reflection. The angle of incidence is less than 48 degree. That is the critical angle of the water droplet, and if it is below this 48 degree, it completely reflect back to the raindrop itself. So after this raindrop, it again undergoes a refraction at the third point of incidence of the in the raindrop, and it emerges with the incoming sunlight as 40 degree for the violet light, and it emerges 42 degree from the incoming sunlight for the red light. So this is for a single raindrop. And if you are considering a primary rainbow, how a primary rainbow happens, how a primary rainbow forms, okay, we have to consider two rainbow to explain this one. So when sunlight enters the raindrop 1 and raindrop 2, you can see that from the raindrop 1 there is a red light from the raindrop 1, that is the lower part. From the lower part there is a red light is coming, it enters the eye, and at the same time from the raindrop 2 a violet light is coming. So the red light we can see it is appears on the top of the rainbow, and the violet light from the raindrop 2, it appears on the bottom of the rainbow. So there are other two rays are coming, but they are not entering to our eyes. It is below and above the eye direction or eye position, so we cannot see those lights. So this is the formation of a primary rainbow, how we are observing a primary rainbow, how we are what is the reason behind the primary rainbow observation. This is the basic idea. Thus the observer sees a rainbow with a red color on the top and violet on the bottom, and this primary rainbow is a result of three-step process. This is a secondary rainbow formation. In this formation there are three different cases are there. First one is a four process. Here four process are there, two internal reflection, one refraction and dispersion are there, so it is a four process. And second one we can say it's a four process. After that we can say its intensity of light is scattered, means two reflections are there, so transmission it is not completely transmission, so some of the part will lose, so intensity of light is very less here, so it is a faint phenomenon, faint effect. So third one is the order is reversed, it is not the same order, it is just as the opposite of the primary rainbow. Second phenomenon is scattering of light. Here scattering of light means we know that as light enters the atmosphere, there are particles that has the particle size, if we consider a, the size of the particle raised to lambda, we have two situations: a very less than lambda, or a very greater than lambda. So depending on the size of the particle, sometimes if a very less than lambda, Rayleigh scattering happens, which means shorter wavelength. If a is very less than lambda, the scattering is 1 by lambda raised to 4 percentage. So we can say that as wavelength increases, the less scattering happens. As wavelength decreases, it scatters more. So violet light scatters more, and red light scatters less. So in most of the part of the sky you can see this phenomena. So scattering happens and we can see the sky as a blue color. Why it is not violet means violet is not sensitive to our eyes, so we see it as blue color. And the other thing is, when we when the sunlight hits on the particles with size a very greater than lambda, what happens means it scatters all the lights, so you can see all the colors you can see. So it appears as white, and some of the materials in the atmosphere you can observe it as white. So for example, cloud you can see as white. This is the reason behind it. In cloud you can say raindrops are there, large dust are there, and ice particles are there. So due to all this phenomena, it appears as white, and other things appears as blue.